In example 1, you were introduced to substituting x values into a function.
William Moore Jr., please come to the office.
And by substituting an x value into a function, you were able to determine the solution or the y value or the f of x that goes along with that. Here in example 2, however, we're going to use a function table. The same thing still applies, right? We need to be able to organize the input, the equation, and the output into a function table. So notice we have here x values and the function that they gave us or the equation, and we're hoping to determine the y values or the f of x. Now notice, as we learned a couple lessons ago, the domain is the list of the x values that are part of this problem. The range are part of the f of x or the y values that would be part of this function. Another way of writing that is remembering that this is the independent variable and this is the dependent variable. Well, let's get started. By making a function table, we make this an easy task. We simply choose values for x and then substitute them in. So we want to choose very simple numbers to start off with. I like to use at least one negative number. So let's go with -1, and then we're going to try 0, +1, +2. And all I'm going to do now is rewrite this rule right here, but instead of x, I'm going to put in the value that I chose for x. So for example,
if you have William Moore Jr., please call the office. William, if you're in the building, please come to the office.
Sorry, I apologize for all these announcements, but let's keep going on. -1, I would now write in place of x, so -1 plus 5. And as we all know, -1 plus 5 would be 4. If I were to put 0 into this equation, I would end up with 0 plus 5, which would be 5. If I rewrite this for 1 plus 5, that equals 6. And hopefully by now you can see a pattern, but 2 plus 5 would equal 7. And now the nice thing is, we can take all of these and make them coordinate pairs. So I can take the x value and the y value, and I can make this a coordinate pair of 1, 4. So if I need to graph this on an equation, I simply put one point at -1, 4, and then I would have 0, 5, so I could plot another one at 0, 5. The nice thing about that 0 is it tells us that this is the y-intercept. And then, for good measure, you would probably want to graph at least one more, 1, 6. So I've easily come up with 3 points that I can graph. Another nice thing that they ask you to do then is to list the domain and the range. So the domain for us in this problem is going to be a list of all the x values. So we're going to use -1, 0, 1, and 2. Okay? And then the range would be a list of all the outputs, okay, the f of x. And for this problem, that would be 4, 5, 6, and 7. Okay? All right, hopefully this is making some sense to you. Let's try one more. I want to do one more real quick just to show you how easy and quickly you can do this. If they give you a function, 4x minus 1, we simply make a quick table. So my x is going to be here. My rule or my function is 4x minus 1. And then my f of x or my y value or my range would be over here. So now it's just a matter of choosing some quick values. If I choose 0, or let's say -1, 4 times -1, which would be -4, minus 1 gets us -5. If I tried 0, 4 times 0 minus 1, well 4 times 0 is 0, minus 1 would be -1. Let's try one more, let's use 1. 4 times 1 is 4, minus 1 would be 3. All right, and there you have a function table with your domains here and your ranges here, and you would be able to choose any one of these and create a coordinate pair that you could graph. Okay, so this is how we put our inputs, our equations, and our outputs and form function tables to come up with domains and ranges and coordinate pairs that we can graph. I would like you now to go ahead and try the got it. I think it is at the top of the next page.